I'm Chelsea Palmer, aka Chisel, and this is Alex Salkeld, aka Doge, and this is the third session of Nakamoto 101, where we explain the sections of Satoshi Nakamoto's Bitcoin Whitepaper in tiny chunks. So this is the shortest section of the white paper, timestamp server, and I must admit this was where I faced my first hurdle in comprehending how to translate the white paper to other people, because timestamp server is not a term that comes up often in crypto Twitter or the end user Bitcoin community. But after discussing with Doge, I understand now that essentially what's being termed a timestamp server here is the confirming and appending function behind the Bitcoin blockchain's cryptographic proof model. So Doge is going to explain a bit more in depth what hashes and timestamps are and how they work.
Now, a timestamp, as you can guess, is probably just a stamp of when something happened. It's the hash where things get a little bit more interesting. Now, a hash, usually, as you'll see it when you're on the internet, you might notice a large amount of numbers and letters, some of them capital, up in your address bar. So that's usually a hash. A hash can be used to identify something, or it can be used to prove that a piece of larger data is real or is accurate. A good example of this is you can take an entire book and run some math on it, and it will spit a string of numbers and letters. There's a whole bunch of numbers and letters. And now at any point in time, anyone else can do the same math onto all the words in the book in that order, and it will always come out the same. If you were to change one thing in the entire book, every number and letter would be different, and there'd be no linking the two. It wouldn't look like it came from the same place at all. So using this, Bitcoin takes all the data that's being broadcast about where coins are moving and compresses it into hashes, into a single hash that says, this is the data, and then beside it puts a timestamp. Now those two pieces of data now represent all of the transactions that happened, and all the transactions can be looked up there. Now when you take those two pieces of data and you attach them to the next group of transactions, is where the interesting, is where the fun happens, I guess you'd say. Now you've taken events that happened, 10 minutes ago, and you've put them with events that happen now. And as you keep building on this, you get a series of where coins are moving in each block of data. So it's kind of like they're chained together, which is why...
A blockchain, you say?
Which is why we stopped saying words like time chain, and we start saying words like blockchain. And if you'll note, interesting fact is that the word blockchain never appears in the white paper.
Time chains in the future, but we made it be blockchains. So thank you for joining us, and see you next time.